Okay. So we'll discuss doubts on electrostatics. Let's start with the booklet first. I'll share the booklet. Okay. Tell me question bank. Let's start. Section A. Any doubts? A3. Okay. A1. Any doubt? A1 में कई लोग ने कुछ लोगों ने पूछा कि सर आंसर शायद सी आ रहा है और डी दिया हुआ है, ऐसा कुछ कंफ्यूजन था. तो जस्ट टू क्लैरिफाई दैट, यहाँ पर charge particle, there are two charge particles, right? You have to find out the force on the charge which is at the origin, okay? Not the force on the charge which is at Q1. See if you're clear with this. Force on Q1 निकालना होता तो ये F आता, but since you have to find out the charge on the force on the charge particle which is at the origin, you'll have to find F and then write the answer as minus F, okay? Equal opposite action reaction etc. Okay, so the answer I think is D Delhi or whatever, right? क्या आंसर आ रहा था इसका? Anyone give that? B Bombay?
D से.
D Delhi, okay. See if you're clear with this. So I think the confusion was between B and D. कि B नहीं, B आ रहा था कई लोगों का और D आंसर दिया हुआ था, तो B नहीं होगा because force on Q1 is not asked. दूसरे वाले चार्ज पे force पूछे. So you'll have to be very careful in such questions, right? Next, A3 solve करते हैं. There are two bodies with identical bodies दिया हुआ है. 40 or minus 20 charge है and they're at some distance apart. So I can say that the force is proportional to what? Product of the charges. If I'm not interested in the direction, then I can just write it as product of the magnitude of charges. So यहाँ पे 40 into 20 होगा. Okay. And now when they are touched, what will happen? When they are touched, the total charge adds up to what? Total charge is 20. 40 and minus 20 will add up to 20. And that will get distributed into 2. Why will it get equally divided? Because they are identical bodies, okay? And so I can say that the charge Q1 dashed and Q2 dashed will now be what? 10 each. And so the new force F dash can be written as what? The new force F dash can be written as written to be proportional to 10 into 10. Okay, na? So F is F by F dash is 8 by or 800 by 100. देखो समझ में आया नहीं? F by F dash is 800 by 100. तो 8:1 का रेशियो हो गया. Initial to final निकालना है 8:1. See if you're clear with this. Yes.
Yes.
Okay. Next. Which question? A4. Okay. A4 में the forces F on each other, the value of R at which they experience the force 4F and placed in a dielectric medium of dielectric constant 16. तो डाइलेक्ट्रिक मीडियम में फोर्स चार्जेस प्लेस करने से ऐसे ही फोर्सेस घट जाते हैं, राइट? बट आई वांट द फोर्सेस टू इंक्रीज. इफ द फोर्स इन वैक्यूम इज F, then what is the force in the medium? The force in the medium is F by K, right? The force in the medium is F by K, right? If I call this as F naught and I call this as F, then I can say that F is equals to what? F naught by K, but that is at same separation. तो यहाँ पर अगर मेरे को फोर्स को 4 times करना है, I want the force to be 4 times, right? So this would have been F naught by 16 ideally. अगर same distance R पे रखते जितना पहले था, then it would have been F by 16. But I want to increase it to 4F naught. So how would I do that? You'll have to decrease the distance. Okay, so I can write down F naught is given as what? F naught is given is proportional to 1 by r square. Force is proportional to 1 by r square. And now this force F is proportional to what? 1 by k into r dash square. K is what? K is 16. Okay. And I want this F to be what? I want this F to be 4F naught. So I can just divide the two things again. तो हमेशा ये ratio proportion types से solve करना best होता है. Instead of writing the entire expression and then solving it, so I can write it as F by F naught as what? K into या फिर F naught by F if I write. Okay, if I write it as F naught by F, what will that be equals to? K into r dash square by r square. Okay, and what do you want F to be? I want F to be 4F. See if you're clear with this. K का value 16 put करेंगे और r dash आ जाएगा in terms of r. F naught and F naught will cancel off. Okay, please go through it. 64 r dash square is equals to r square, so I'll get r dash as r by 8, I think. Please go through the simple formula based sums. Next, और क्या doubt है? Section B. Section B.
B4.
Okay, B4. Charge particle Q, mass m is released from rest in a uniform electric field. Uniform electric field है, so I can say that the force will be constant Q into E, and so the acceleration can be written as QE by m. And you have to neglect gravity. Kinetic energy निकालना है after t seconds. इसमें क्या पंगा हो गया? Kinetic energy is half mv square और v की जगह a into t लिखेंगे. So half into m into q square e square by m square into t square. नहीं आया इससे? क्या आ रहा है? q square e square by 2m into t square. ठीक है?
Yes, sir.
कुछ भी नहीं था यार. Anyways, next section C. Section C, any doubts? Section C.
C4.
C4 यूनिफॉर्मली चार्ज सेमी सर्कुलर रिंग है. तो रिंग्स के बारे में डिस्कस किए थे कि कैसा भी चार्ज डिस्ट्रीब्यूशन हो, हाफ रिंग पे चार्ज हो या अनइवन चार्ज हो या यूनिफॉर्म चार्ज हो, यहाँ पर हाफ रिंग पे चार्ज है. दैट इज द एक्सप्रेशन फॉर पोटेंशियल विल नॉट चेंज. ओके, द एक्सप्रेशन फॉर पोटेंशियल एट दैट पॉइंट p x x डिस्टेंस अवे विल बी गिवन एज व्हाट? ये रेडियस r है, तो विल बी अंडर रूट ऑफ kq स्क्वायर kq by distance r small r, right? This is perpendicular length. चाहे जैसा भी चार्ज डिस्ट्रीब्यूशन हो रिंग पर, पूरा सेमी सर्कुलर रिंग हो, what is the idea? The idea remains the same. The idea remains that all the charges are at what distance? All the charges are at the same distance from that point. That is what matters. वो चार्जेस कैसा डिस्ट्रीब्यूटेड है रिंग पे डज नॉट मैटर. चाहे हाफ रिंग पे पूरा चार्ज हो, ओके, या फिर uneven charge distribution हो, none of that matters, right? I can just say that all these charges are smaller distance away, and smaller is what? R square plus x square. So the potential will be kq by r. Go through it please. आधा रिंग पे हो या रिंग के सिर्फ एक पॉइंट पे पूरा चार्ज हो तो भी सेम ही एक्सप्रेशन है, या पूरा रिंग पे हो या एक रिंग हाफ रिंग पे ज्यादा हो, हाफ रिंग पे कम हो, व्हाटएवर इट इज, राइट? Potential likhna is always very easy for a ring. Electric field likhna is difficult. Electric field, when will the electric field be along the axis? That will happen only when the charge is uniformly distributed. Okay. So that's question number C4. Next.
Sir, C8.
C8. यहाँ पर पोटेंशियल डिफरेंस बिटवीन द पॉइंट्स ए एंड बी निकालना है. ओके, तो अगेन यूनिफॉर्म इलेक्ट्रिक फील्ड है, तो व्हाट कैन आई से? यूनिफॉर्म इलेक्ट्रिक फील्ड है तो इक्विपोटेंशियल लाइंस विल बी परपेंडिकुलर टू द इलेक्ट्रिक फील्ड. ऐसा, दीज आर इक्विपोटेंशियल लाइन. तो आई कैन से कि बी पे जो पोटेंशियल है वही पोटेंशियल सी पे होगा. वीबी इज इक्वल टू वीसी, इक्विपोटेंशियल लाइन. Okay, for a uniform electric field, equipotential lines are parallel to each other and perpendicular to the field. Okay, now potential difference between A and C को आराम से calculate कर सकते हैं. A से C जब जा रहे हैं तो you're moving opposite to the field, so the potential will increase. Okay, तो VA पे जो potential है plus what is the formula for potential difference? E into D is equals to VC और D का value कितना है? B. So I get VC as what? I get मेरे को निकालना है potential difference, right? तो potential difference VC minus VA can be written as E into D. और जो पोटेंशियल सी पे है वही पोटेंशियल बी पे है, तो वीबी माइनस वी इज आल्सो ई इनटू। देखो समझ में आया है?
यस।
और कोई तरीका इस क्वेश्चन को करने का? इंस्टेड ऑफ यूजिंग द फैक्ट दैट बी और सी आर सेम पोटेंशियल पॉइंट्स, एनी अदर वे? ए और बी के बीच में डायरेक्टली अगर निकालना होता तो क्या करते? आई वुड हैव फाउंड द कंपोनेंट ऑफ इलेक्ट्रिक फील्ड अलोंग द डायरेक्शन। तो ये ई इधर है तो इधर कंपोनेंट क्या आएगा? इफ दिस एंगल इज थीटा देन इट विल बी ई cos थीटा. If this is E, this component will be E cos theta. And how much did I move along this direction? How much did we move along this direction? B by cos theta. ये right angle triangle है तो ये length B है तो this will be B by cos theta. The potential difference for a uniform field can be written as component of electric field into the distance that I moved. How much is the component of electric field? E cos theta. And how much is the distance that I have moved? B by cos theta. एक ही बात है. So cos theta cancels off. I get EB. Okay, next, which question? Next, section C, any doubts? Section D. C, any doubts? D.
D1.
इसका डाउट है? D1.
Yes, sir.
Okay, Karan. Charge moves from high potential region to low potential region. You have to find out the electrical potential energy. तो high potential से low potential में जा रहा है तो change in electrostatic potential energy can be written as Q into V final minus V initial. So V final minus V initial will be what? Negative value. ठीक है ना? But charge अगर negative होगा तो क्या delta U will become positive. This may be positive, this may be negative. Okay. So if it is positive, then delta U will be negative. Potential decreases. That will depend upon the polarity of the charge. अगर charge positive है तो potential will decrease, and if the charge is negative, then the potential will increase. So may decrease or increase. Please go through it. और
Yes.
बताओ next doubt.
E3 sir.
Okay. D में D2 E E3
E2 also.
E2.
Yes, sir.
हाँ E2 में शायद कुछ प्रिंटिंग एरर था क्या? Anyone who solved it?
नहीं सर।
आ रहा था आंसर. तीन चार्जेस दिया हुआ है
Answer.
Q, 2Q और XQ, and they are placed at finite distance, equal finite distance, so that the electrical potential energy of the system is zero. Electrical potential energy of the system is zero. ऐसा placed है? Yes. Q, 2Q and XQ. Yes or no?
Yes, sir.
They are separated by equal finite distances so that the electric potential energy is zero. हाँ तो x का वैल्यू निकालना है तो ये डिस्टेंस दी है तो पोटेंशियल एनर्जी का कितना टर्म्स होगा? There will be 3 terms, and so I can write on the first term as what? 2Q squared by D, K into Q into 2Q, right? The next term will be what? K into Q into XQ, right? So K into XQ square by 2D, and the third term will be K into 2Q into XQ, so that will be K into 2X into Q square by D, and this should be 0. तो यहाँ से x का वैल्यू निकालना है, आ जाएगा?
Yes, sir.
क्या एक्सप्रेशन आ रहा है? 4Q स्क्वायर प्लस XQ स्क्वायर plus 4x into q square भी cancel off कर सकते थे of course. So you'll get x as sorry क्या mistake है मैं ठीक है क्या yes I can find the value of x from this.
So ये इक्विलैटरल ट्रायंगल नहीं हुआ क्या, क्योंकि इक्वल फाइनाइट डिस्टेंसेस बोला.
x का वैल्यू यहाँ से इक्वल फाइनाइट डिस्टेंसेस. हाँ ये एक्चुअली वही मैं बोल रहा हूँ, इस स्टेटमेंट में थोड़ा सा वो है कंफ्यूजन. इट माइट बी इट शुड हैव बीन गिवन या इक्वल डिस्टेंसेस फ्रॉम ईच अदर. तो यहाँ पर ये यू कैन अस्यूम इट एज अ इक्विलैटरल ट्रायंगल एज वेल. तभी फाइनाइट सब सेम डिस्टेंस होगा, नहीं तो यहाँ पर इस दोनों के बीच में 2D हो जाएगा. बट यस द क्वेश्चन इज
इसका आंसर आ रहा.
but the question is slightly unclear. It should have mentioned that the charges are placed in a straight line. या फिर they must have given that the charges are they're all equal distances from each other, equal finite distances separated by, because this term separated is not a separated by equal finite distances from each other is type of, there have been some more explanation to this statement. Because this also could be guessed from what is given in the statement. यहाँ से आंसर क्या आ रहा है बाय द वे? -4/5. -2/3. X का value is coming out as -2/3. But then yes, the statement should have been more clear. Right? Anyways, next section F तो अभी रहने दो, not needed. E3. हाँ E3 में इस तरह से समझने की कोशिश करो. अपन पोटेंशियल ऑफ ब्लॉक ऑफ मास m kept at a height h mgs लिख सकते हैं. कब लिख सकते हैं वो? when we assume a reference level, then we can write down the potential energy as mgh. but if I change the reference level, if I और इस ब्लॉक का पोटेंशियल एनर्जी then can be said to be -mgh, okay, with this reference level. But if I change the reference level, then the potential energy का value will change. If I assume this as the reference level, तो इसके हिसाब से potential energy इसका 0 हो जाएगा और इसका हो जाएगा -2 mgh, okay. but अगर potential difference निकाले तो दोनों ही केस में सेम आएगा, right? In the first case, delta u will be what? ये plus mgh, ये minus mgh, so delta u is 2 mgh, okay. u1 minus u2 अगर करते हैं तो I'll get it as 2 mgh. और यहाँ पर भी ये second case में भी the potential difference will come out as 2 mgh. ठीक है ना? It will be 0 minus of -2 mgh, so it will come out as 2 mgh. So what is the conclusion? That potential energy का difference does not depend upon the reference level, okay. Potential energy का difference does not depend on the reference level, but absolute potential depends on the reference level. समझ में आ रहा है?
Yes, sir.
See if you're clear with this. तो अपन जो भी इक्वेशन लिखते हैं KQ/R, उसमें भी assume कि infinity पे potential is 0, normalization of potential, and based on that we say that potential at that point is KQ/R, है ना? That is the idea. तो कोई भी दो पॉइंट का पोटेंशियल अपने लिखते हैं, पोटेंशियल एब्सोल्यूट पोटेंशियल से ज्यादा पोटेंशियल डिफरेंस जरूरी है, जस्ट एज एब्सोल्यूट पोटेंशियल एनर्जी से ज्यादा पोटेंशियल एनर्जी का डिफरेंस जरूरी होता है इन वर्क पर एनर्जी. सेम थिंग ओवर हियर. आई कैन असाइन एब्सोल्यूट पोटेंशियल ऑफ दिस पॉइंट एज 0 volts and absolute potential of this point then let's say is 5 volts. तो अगर इसको मैं चेंज किया V1 को, suppose if I make V1 as 10 volts, then V2 will automatically become what? V2 will automatically become 15 volts. Does that? The difference will remain constant. Okay. So it is the potential energy difference or the electric potential difference which is more important and is independent of the reference level. Independent of the reference level. Okay. Let's move forward next. G.
G1.
G1. Electric field intensity at a point in space is equal in magnitude. So the potential gradient there. What do you mean by potential gradient? Potential gradient matlab the rate at which the potential changes with distance, delta V by delta R. वही होता है इलेक्ट्रिक फील्ड का एक्सप्रेशन है ना, माइनस डेल्टा वी बाई डेल्टा आर लिखते हैं, बट मैग्नीट्यूड लिखने तो इट इज डेल्टा वी बाई डेल्टा आर, राइट. कोई भी चीज का ग्रेडियंट इज हाउ इज दैट क्वांटिटी वेरिंग विथ डिस्टेंस. ओके, delta of that value over distance is what is known as the gradient. टेम्परेचर ग्रेडियंट होता है डेल्टा टी बाई डेल्टा एक्स, वैसे ही पोटेंशियल ग्रेडियंट है डेल्टा वी बाई डेल्टा एक्स एंड सो. ओके, नेक्स्ट. नेक्स्ट जी, एनी डाउट्स? G2, G3?
G3.
G3. ओके. G3 में फोर्स निकालना है ऑन द 2 कूलम चार्ज प्लेस्ड एट द ओरिजिन. If you place a 2 coulomb charge at the origin, the force will be Q into E, and electric field can be written as what, minus of dV by dr. So it is negative of the slope of a VR graph. Now the slope of this graph is what? The slope of this graph is 5 by 2. So minus of 5 by 2 volts per centimeters. देखो units are important over here. But volts per centimeter is not a good thing to use in this equation F equals to Q into E. Why? Electric field का ऐसा unit is what? Volts per meter or newtons per coulomb. Please remember this. 1 volt per meter is also 1 newton per coulomb. तो volts per centimeter को पहले volts per meters में convert करेंगे. कैसे convert करेंगे? I'll multiply it by 100. 1 सेंटीमीटर दूरी में 2.5 volts का change है, तो 100 सेंटीमीटर की दूरी में 250 volts का difference होगा. Okay, so 250 volts per meter. See if you're clear with this. Which is also 250 newtons per coulomb. Volts per meter can be replaced as newtons per coulomb. And now the charge is 2 coulombs. So what will be the force? 500 newtons. Please go through it. Force will be Q into E. 2 into 250. So 500 newtons. Yes or no?
Minus no sir.
हाँ, माइनस वाला ऑप्शन दिया हुआ है क्या? हाँ, माइनस वाला दिया हुआ है तो माइनस होगा. माइनस वाला ऑप्शन दिया हुआ है तो माइनस 500 न्यूटन. देखो समझ में आया नहीं? So the answer is DW, right? Next, 4 to 6, G4, G5, G6. G6. Anyone having doubts with G6? G6 में कोई डाउट?
Sir, G5.
G5 में a uniform electric field E0 is directed along the positive x-axis. The potential is 0 at x equal to 0. So potential at plus x will be what? It's simple. Let's try to solve it. Electric field is in the positive x direction, and at origin it is given as the potential is given as 0. At x0, how much is the potential? So you're moving along the electric field. So पहला बात तो ये the potential will decrease. And since it is a uniform electric field, what else can be said? We can say that delta V can be given by what? E into D. This is only valid for a uniform electric field. For a uniform field, this is valid. Okay. अगर uniform non-uniform field है, then you'll have to use what equation? E equals to minus dV by dr, या फिर dV by dx, and so on. These calculus equations have to be used when there is a non-uniform electric field. For uniform electric field, you can always write this equation. Delta V as E into D. So it will be E0 into x. And since the potential has decreased, it will be minus of that value. Minus of E0 into x. Go through it, please. G6 में electric field not 0, potential cannot be 0. Is it true?
So it is false.
Can you give me
Also.
an example where E is non-zero but V is zero?
So दो charges और perpendicular bisector पे अगर करें
Yes, if I take two charges, plus Q and plus Q and minus Q, then midpoint पे क्या होगा? Electric field zero या non-zero?
0.
Electric field zero या non-zero?
0.
कैसे zero? Positive
Potential
charge के लिए
zero
the
यार
field
इसमें.
will be repulsive और negative
Zero.
charge के लिए the field will be attractive. Electric field तो add up हो गया यार. Zero कहाँ से होगा?
Potential 0.
Potential is zero. So this point, this option A has been disproved. E non-zero, V can be zero. Statement B is if E is zero, V must be zero. If E is zero, V must be zero. Is it correct?
No sir.
Can you give me an example otherwise?
Center of a ring.
E is zero, but V and V is non-zero. ऐसा कुछ निकालना है. So I can say that two equal charges अगर लेते हैं plus Q, तो midpoint पे electric field क्या है? Zero है. Why? Because the electric fields will cancel this time. What about the potential? Potential will add up. दोनों positive potentials है, तो potential will be positive. So V must be zero is wrong. If V is zero, E must be zero. If V is zero, E must be zero. ये भी already wrong proof कर चुके हैं. So D is the answer. So please remember this. ये दो important examples है, right? ये दो important cases है. So what can you say about the two cases? यहाँ पर चार्ज कोई एक तीसरे चार्ज पार्टिकल को लेके आएंगे तो वर्क डन करना होगा या नहीं करना होगा? In the first case, if I bring a third charge particle from infinity to this point, will I have to do work? Potential zero है, तो work done will be zero. Okay, the work done in the journey will be zero. But यहाँ पर मैं charge particle को release नहीं कर सकता. I'll have to hold the charge particle. Right? Why? Because there will be an external force, there will be an electrostatic force which you have to balance to keep the charge at rest. है ना? तो यहाँ पर journey में work नहीं करना पड़ा, but when you reach the destination, you have to toil, you'll have to hold the charge particle. In the second case, when you bring the charge particle from infinity, will you have to do work? Potential is positive there, so the work done will be positive in the journey. But you can release the charge particle. The external force needed at that point P will be zero. Why? Because the electric force is zero. तो यहाँ पर जर्नी में वर्क करना हुआ, डेस्टिनेशन पे यू कैन रेस्ट, बट इन द फर्स्ट केस जर्नी में वर्क नहीं किए तो डेस्टिनेशन पे यू विल हैव टू यू नो अप्लाई फोर्स एंड होल्ड द चार्ज देयर. Okay, please remember the two cases, very important. Next, H, section H, any doubts? Yes or no? H.
1.
H1. Electric field intensity parallel to the dipole axis निकालना है. कहाँ पे होगा electric field parallel to the dipole axis? Dipole axis ऐसा है, dipole moment ऐसा है, तो electric field along the at all the axial points, the electric field is along the dipole axis. At P and at P dash, they are both along the dipole moment, and at the equatorial points, it is what? At the equatorial points, it is opposite to the dipole moment. How much is the value? ये वाला value कितना होता है? This is 2 kp by r cube. This is also 2 kp by r cube. And what is the electric field at the broadside on position?
KP by R.
KP by R
Kp by 2 half. Okay, kp by r. Please remember the values. So it gradually changes the direction from rightwards to leftwards, and it also gradually changes the magnitude from 2 kp by r cube to kp by r cube. ये वाला value अगर E naught है तो this is E naught by 2. Okay, we had discussed it in the last Zoom session. The electric field direction and the magnitude gradually changes as it goes, as you go from end on position to broadside of position. Next. Section H.
So H4.
H4. Okay, H4,
Sir, H2.
H2. Dipole moment P along the x-axis, the angle made by the electric field at the point P on the x-axis. The point P whose position is at an angle theta from the x-axis. Let's try to draw the diagram first. It is always important to first draw the diagram for the question given so that you can visualize and work accordingly. Okay. So this is the x-axis, y-axis. Let's say dipole is placed on the origin. So this is the dipole. And electric field at point P निकालना है, which is having a position vector r, making an angle theta with the x-axis. तो ये point P का इलेक्ट्रिक फील्ड निकालना है, इसमें क्या पंगा हो गया? ठीक है, तो ER और E थीटा होता है. तो in the last Zoom session itself, we had discussed about this in lot of details. This is ER and E theta, so the resultant electric field will be given by the diagonal. This will be the resultant electric field, and we say that this makes an angle alpha with the radial component. ये ER है, ये E theta है. ER itself is making what angle with the horizontal line with the x-axis theta. ये वाला angle और ये angle तो theta ही होगा corresponding. So how much is the total angle that the electric field vector is making? Theta plus alpha. Yes or no? ठीक है, x-axis से the entire angle is theta plus alpha. Go through this.
And so alpha will be like this tan alpha equal to half tan theta will be applicable for all.
Yes. हर point के लिए value है. Last Zoom session attend नहीं किए थे क्या दोस्त? Yes. हाँ, तो देखना चाहिए था. At least बाद में देख लेना चाहिए. Not good. Anyways, next. वापस से please guys, because online हो गया है, please do not slack, right? You guys were again, coming into good form with that of when those, 2-3 months, 3 months we had offline classes. But again, you guys are slowly losing all into, right? All gusto, which is not good. You will have to keep going because those who will do well ultimately will be the ones who keep going, right? Or जो बीच में just frustrate होके या whatever be the circumstances, who just if you give up in between, you're out of the race. Okay. Anyways, next, any other doubts?
Sir, H7.
H7, okay. उसके पहले कोई doubt? No. Fine. Yeah, H7. This also we had discussed in the last Zoom session. दो dipoles है अगर और force निकालना है दोनों के बीच में, तो force is inversely proportional to r to the power 4. Why? Because if I assume a dipole P, what will be the electric field? Anyone who solved this question? R to the पे electric field का क्या expression होगा इस केस में? 2 kp by r cube, because it is a broadside, it's an end-on position. So force on a dipole in it's a non-uniform electric field. Okay, it is not a uniform electric field. Non-uniform. So non-uniform में what is the formula? P d by dr. तो यहाँ पर dipole moment क्या है? P dash, और electric field कितना है? 2 kp by r cube. तो इसको differentiate करेंगे तो I'll get it as -6 kp by r4. So inversely proportional to r to the power 4. Please remember this. ठीक है. और अगर ब्रॉड साइड ऑन पोजीशन पे रखते डाइपोल को तो कितना फोर्स होता? यस,
-6 हो जाए -3 आ जाए.
3 आ जाता बिकॉज वहां पे 2 पर द फैक्टर कम है बस. और ओके, नेक्स्ट सेक्शन I is not needed now for next week. There are a few problems here. Okay, section J.
Sir, J4.
J4.
J3.
Okay, J3 as well. 3 concentric shells है, 4q on the inner shell, -2q on the middle shell, and -5q on the outer shell. The charge on the inner surface of the outer shell. Okay, simple questions here. We'll just draw 3 concentric shells. Okay, and now we'll write on the charges. अंदर वाला कंडक्टर पे जो भी चार्ज देंगे वो पूरा का पूरा उसके बाहर सरफेस पे जाएगा, बिकॉज कैविटी में कोई चार्ज नहीं. सो लॉन्ग एज देयर इज नो चार्ज इन द कैविटी, द चार्ज ऑन द इनर सरफेस विल बी 0. Okay, so the charge 4q will be on the outer surface, and so on the inner surface of conductor 2 the charge is minus 4q. What is the total charge on the conductor 2? Minus 2q. तो बाहर वाले सरफेस पे कितना आएगा? प्लस 2q. तभी माइनस 2q होगा नेट, और यहाँ पर प्लस 2q तो इधर पे माइनस 2q होगा. फेसिंग सरफेसेस मस्ट हैव इक्वल ऑपोजिट चार्ज. सिंपल रूल्स. Charge on the innermost surface, inner surface of the innermost conductor is 0 if the charge in the cavity is 0. Facing surfaces equal opposite charge, and total charge on the conductor will remain what it was. Okay, charge conservation. So minus 2q है और बाहर पे minus 3q है. आंसर क्या है? minus 2.
माइनस, हाँ सर, आ गया.
Next, J4. Charge Q is uniformly distributed over a large plastic plate. Electric field P just above is 50 volts per meter if the plastic plate is replaced by a copper plate of the same magnitude. Okay. This will be from Gauss law. You can leave it now. Okay, you can leave it now. और बोलो. Next.
सर J13.
Okay, J13. उसके पहले कोई डाउट?
Sir, J12 also.
J12. ये सब हो गए थे. 5, 6, 7, 8. J8.
सर J9 का क्या रीजन है?
सर 9 का रीजन.
Okay, J8 पहले करते हैं. Two small conductors A and B are given charges Q1 and Q2. Now they are placed inside a shell carrying charge Q. A and B are connected. A, B, C are all connected. Charge क्या होगा? तो इसमें क्या प्रॉब्लम हो गया? When you connect, what will happen? The potential difference should be 0. So अगर potential difference 0, there should be no electric field lines. If there are no electric field lines, there should be no charge. क्योंकि पॉजिटिव चार्ज होगा तो फील्ड लाइन बाहर आएगा, नेगेटिव चार्ज होगा तो फील्ड लाइन अंदर जाएगा. आई डू नॉट वांट फील्ड लाइंस एट ऑल. Since the potential of the entire region, this entire region just becomes an equipotential region. This entire volume becomes an equipotential region. That is it. So ये कब होगा? When there is no charge inside. All charge will move to outside. Okay. So how much will be Q out? It will be Q plus Q1 plus Q2. Okay. That's J9. You're traveling in a thunderstorm. What would you do? बताओ क्या करोगे? Remain in the car. Take shelter under a tree. Get out and be flat on the ground. Touch the nearest electric pole. D करोगे कोई? D नहीं करोगे. Okay. Why not remain in the car?
Remain in the car.
Why? तभी जाएंगे बाहर.
Electrostatic shielding.
Electrostatic shielding, right? Car is a conductor. तो बाहर में जितना भी लाइटिंग हो, you are safe inside the car. It does not look like a car anyways. So electrostatic shielding. That's the simple reason. You know? Whatever lightning etc. happens, you are insulated from the outside. Right? Okay. Next doubt.
J30.
J13.
J12 भी किसने बोला सर?
Yes, sir, J12 also.
Okay. J12 let's solve first. और फ्लक्स के ऊपर है यार. फ्लक्स छोड़ दो. फ्लक्स में प्लस.
Okay, sir.
J13. J13 is on electrostatic pressure. Okay, electrostatic pressure wala idea we have discussed in capacitors, because there's a link to capacitors, right? So that will be discussed when we do capacitors. Okay. Next.
Sir, part 2, question 3.
Part 2, question 3. Potential at the center of the circle. Oh, part 2, sorry. ये वाला?
हाँ सर.
Okay. Potential at the center of the circle निकालना है. ये तो simple ही है. सेंटर का कोऑर्डिनेट्स पता है हमें? This is 8
हाँ सर.
और x कोऑर्डिनेट ऑफ द सेंटर क्या आया था?
-1.
-4.5.
-4.5. ओके. हाँ तो बस ये Q1 KQ1 बाई R और KQ2 बाई R. ओके. ये R1 है, ये R2 है, राइट? इसमें क्या पता है? That's the potential at the center of the
सर
circle.
वो तो एक कंडक्टर तो नहीं है ना.
Conductor नहीं, it is just imaginary circle at which we are trying to find the conductor. Not a conductor. एक काफी common mistake है. I don't know why many students do this. The moment they see any circle, they get confused between Gaussian surface that we'll do in the next class, conductor, and equipotential surface. Right? There are three different things. Gaussian surface, equipotential surface, and conducting surface. Conductor का surface are three things. Okay, people confuse it into one, right? Conductor की जगह या तो Gaussian surface assume कर लेते हैं, and so on and so forth. This is an equipotential line. Okay, this one is an equipotential line. Potential हर point पे 0 है. This is an equipotential line. Okay. EFL ये सब चीजों में confuse हो जाते हैं लोग. I don't know. So be very clear with what is there. Okay, what is asked in the question. Next. Any other doubts? Objective questions?
Sir, can you discuss number 10?
So 7C and D.
7C. The coordinate of the point on the circle. This again is related to Zoom session 3. Coordinate of the point on the circle where the electric field is 4p by r cube. तो इस दोनों का रिजल्टेंट निकाल सकते हैं. दोनों डाइपोल्स का जो रिजल्टेंट डाइपोल मोमेंट है, दैट विल बी 2p √3 और 2p का रिजल्टेंट, राइट? तो दिस इज द 2p डाइपोल और इसका जो ब्रॉड साइड ये एंड ऑन पोजीशन होगा उस पे इलेक्ट्रिक फील्ड कितना होता है? 2kp बाय r क्यूब. और यहाँ पर p की जगह क्या पुट करेंगे? 2p, बिकॉज द रिजल्टेंट डाइपोल इज 2p, सो इट बिकम 4kp by r cube, राइट? दिस इज 4kp by r cube. So the electric field where 4kp by r cube जहाँ पे होगा ये इधर और इसके diametric opposite. And you can find out this angle, right? Tan 60 और angle 60 होगा. Tan 60 is √3 by 1. Please go through it. Okay. So the coordinate will be what? R cos 60 and R sin 60. और उसका diametric opposite point भी हो जाएगा, right? -R cos 60 -R sin 60. ठीक है. Next. Section ये part D also.
Yes, sir.
पार्ट डी में 2kp by r cube है, तो 2kp by r cube किधर पे होगा? एंड ऑन ब्रॉड साइड ऑन पोजीशन पे, राइट? एट ब्रॉड साइड ऑन पोजीशन द इलेक्ट्रिक फील्ड विल बी kp by r cube and p over here is what? 2p, right? So ये दोनों पॉइंट्स हो गए. ओके. नेक्स्ट. और कोई डाउट यहाँ से?
10.
So number 10.
ओके. 10 में Yeah. So tell me, there's a uncharged conductor, and there's a charge Q inside the cavity. Point P and charge Q as shown. Okay. At distances C and D. Fair enough. Charged particle small q is at a distance a from the center of the cavity. Okay. अभी निकालना है अपने को. We have to answer the questions. Fine. The first of question: electric field due to the induced charges on the inner surface of the cavity at the point P. Yes. Anyone? Will there be electric field at point P due to the induced charges on the inner surface? पहला बात तो induced charges on the surface will be non-uniform. Why so?
Charge is not at the center.
The charge particle is not at the center, and so the charge distribution is not symmetric. So here is sigma inversely proportional to ROC. यहाँ पर the rule is because they are bound charges, they are distributed in a they are non-uniform. They are non-uniform. What about the outer surface? Will the charges be uniformly distributed? No. Why?
Radius of curvature is different.
And
Plus Q is there.
yes, दो reasons हो गए. एक तो radius of curvature is not constant, or there will be induction because of Q. See if you're clear with this. यहाँ पर ऑलरेडी पॉजिटिव चार्जेस ज्यादा आने चाहिए थे क्योंकि यहाँ पर ज्यादा कर्व्ड सरफेस है, राइट. फ्लैटर सरफेस इधर है तो ऑलरेडी पॉजिटिव चार्जेस कम होने थे और कम हो गए बिकॉज ऑफ Q विल इंड्यूस सम माइनस Q डैश एंड सो इट फर्दर डिक्रीजेस. सो द चार्ज डिस्ट्रीब्यूशन is more very high positive on this side and very low positive on the other side. So the charge, but the net charge is small q. Okay. See if you're clear with the charge distribution first. So अंदर भी non uniform है, बाहर भी non uniform है, but the reasons are different. Go through it please. तो इलेक्ट्रिक फील्ड एट पॉइंट P निकालना है. तो व्हाट इज द आइडिया इलेक्ट्रिक फील्ड एट पॉइंट P के लिए कितना क्या लिखेंगे इलेक्ट्रिक फील्ड एट पॉइंट P? Due to plus Q and minus Q, the electric field will add up to 0. Okay. Q के कारण जो इलेक्ट्रिक फील्ड है और माइनस Q के कारण जो इलेक्ट्रिक फील्ड है, the electric field at P due to the charge particle plus the electric field at P due to the minus Q induced charge will add up to 0. Why so? Shielding.
Same in magnitude.
Same in magnitude है because of this reason. Okay, why is this correct? Because of shielding. Okay, the conductor, stops any communication between the outer world and the inner world. तो inner world का जो भी account है वो inner world में close करना होगा. तो point P पे electric field because of the inner world should be 0. Outer world के कारण electric field है चलेगा, but because of the inner world the net electric field will be 0. Okay, so electric field due to minus Q charge पूछा है तो that will be non-zero. समझ में आ रहा है? Electric field at P due to the minus Q charge on the inner surface is equal to electric field of P or at P due to the charge particle. See if you're clear with this. Or direction opposite होगा तो I can put a minus if ever. Clear? Yes or no?
Yes.
Electric potential due to the charges on the inner surface of the cavity and Q. What will that be? Why? Why 0?
So same reason.
Is it the same reason? ये माइनस क्यू का चार्ज डिस्ट्रीब्यूशन जो है, राइट, दिस माइनस क्यू चार्ज डिस्ट्रीब्यूशन is asymmetric. So if you think of a if you think that you replace it by its charge center, तो वो कहाँ पर आना चाहिए तुम्हारे हिसाब से? Where should it be?
Should it be at Q?
Yes. Someone that is the most logical approach because it is a spherical surface. The charge distribution is such that उसका charge center Q पर ही है. And so I can say that in a way the charge minus Q and the charge Q are equidistant from the point P, and so the net potential is zero. Okay. But inner surface of the cavity and inner surface of the cavity and charge Q दोनों के लिए बोल रहा है, तो that is zero. समझ में आता है? अगर सिर्फ inner surface बोलता then it would have been non-zero, but because of both the things they've asked, so it will be zero. Potential due to the plus Q charge particle plus the potential due to the minus Q induced charge is zero. Okay. Next, electric field due to the induced charge on the outer surface of the conductor and Q at C. Electric field due to the induced charges on the outer surface of the conductor. So at point P, what can I say about the electric field? It will be obviously non-zero. दोनों चीज डिसाइड करेगा, राइट? ये प्लस क्यू चार्ज ऑन द आउटर सरफेस और ये प्लस कैपिटल क्यू चार्ज पार्टिकल, दोनों का इलेक्ट्रिक फील्ड होगा इधर पे, राइट? So the resultant electric field here is non-zero because of two things: because of the plus q charge on the outer surface and what, and capital Q charge particle. Non-zero. If you clear with this. Electric potential due to the induced charges on the inner surface of the cavity at C. Inner surface of the cavity at C. Any guesses? सेंटर पे पोटेंशियल क्या होगा? At C, because of the inner charges, inner surface charges. Zero or non-zero? Potential is KQ by R. Potential is KQ by R. So is R zero or non-zero? अभी क्या डिस्कस किए थे कि इसका जो चार्ज सेंटर है वो यहीं पे हो जाएगा, तो से a डिस्टेंस पे है, तो I can say that the potential will be non-zero. This is also non-zero value. Please go through it.
सर
Yes.
C का आंसर P and R दोनों दिया है.
C का आंसर P and R, हाँ वो तो ठीक है. It cannot be Q and R दोनों दिया हुआ है. Which options answer is given as P and R?
Option C, P and R.
Electric field due to the induced charges on the outer surface. Electric field due to the induced charges on the outer surface of the conductor and Q at C. अच्छा at C पूछा है. I'm so sorry, not at P. So sorry. इस दोनों का तो रिजल्टेंट जीरो है obviously. मैं ये पॉइंट P का बात कर रहा था. ओके, अगर मैं इफ आई टॉक अबाउट द पॉइंट C, राइट, देन अगेन आउटर वर्ल्ड इनर वर्ल्ड. आउटर वर्ल्ड का टोटल जो चार्जेस है उसका इलेक्ट्रिक फील्ड अंदर पे जीरो होगा. ओके, द रिजल्टेंट इलेक्ट्रिक फील्ड एट C due to the charge Q, charge particle, and due to the small q induced on the outer surface will be zero. Okay, the outer world will not communicate with the inner world. अगर सिर्फ कैपिटल Q का पूछता then it would have been KQ by T square, और सिर्फ इस स्मॉल q का पूछता then it would have been minus KQ K capital Q by T square. Net field is zero. This will be zero. Okay, this will be zero. Thank you for correcting. Clear है ये?
Individually they will have electric field, but
Of course, but togetherly the net field will be zero. Okay.
so because of the distribution of the small plus q charge.
हाँ, इंडिविजुअली इलेक्ट्रिक फील्ड होगा स्मॉल प्लस क्यू चार्ज के लिए भी और कैपिटल क्यू चार्ज के लिए भी, बट नेट फील्ड विल बी जीरो.
Yes. Sir, I'm telling you.
अब अगर ये कैपिटल क्यू
next-
चार्ज अगर नहीं होता, अगर कैपिटल क्यू चार्ज नहीं होता, then plus q would have distributed in such a way that the electric field inside is 0. Then the electric field at C due to the plus q charge would be 0. But यहाँ पर सिर्फ plus q charge के कारण भी electric field होगा सेंटर पे because of capital Q. Okay.
And so in option D, so the electric potential will be kq by D, kq by B, or kq by A.
Just get back, yeah. In D, electric potential due to the induced charges on the inner surface of the cavity at C. Inner surface of the cavity due to the induced charges. नहीं, D कहाँ से हो गए? हाँ, D तो होगा यार, because सब चार्ज D दूरी पे है
Yes, sir.
है ना, तो
So, sir,
Q by D
we-
होगा.
yes, sir.
Right. Next.
D होगा.
हाँ, सब चार्ज D दूरी पे है.
Sir, at
B
you're
दूरी पे
talking
है.
about
B
option D.
B दूरी पे है.
B.
Yeah. B. It is B distance away, so minus KQ by B, of course.
सर ABCD का ना R and S के फॉर्म में भी आंसर दिया है, so
हाँ, तो जो वैल्यूज अपन डिटरमिन कर सकते हैं, तो वो वैल्यूज जो वैल्यूज 0 है, वो मतलब वो तो ऑलरेडी फाइंड आउट कर लिए, और जो नॉन जीरो है मतलब इट कैन नॉट बी डिटरमिन, राइट, क्योंकि अनइवन चार्ज डिस्ट्रीब्यूशन है, सो ऑन एंड सो फोर्थ, राइट. नेट इलेक्ट्रिक फील्ड एट P अगर कैलकुलेट कर रहे हैं बिकॉज ऑफ द इंड्यूस्ड चार्जेस, दैट वी कैन फाइंड आउट बिकॉज नेट फील्ड P पे 0 होना चाहिए बिकॉज ऑफ Q एंड माइनस Q, राइट. तो ये वाला लेंथ इफ यू फाइंड आउट, देन KQ by R square अगर है तो उसका ऑपोजिट होगा बिकॉज ऑफ द माइनस Q चार्ज. ओके, नेक्स्ट कौन सा क्वेश्चन? Any other question from this exercise 2?
Or 3.
Exercise 2. Let me first shift to DCP and then I'll come back to this exercise 2.
So,
Yes.
I have a question that if there is a solid sphere, solid conducting sphere, and it has a charge plus Q, then the
Mhm.
potential at the center will be 3 by 2 KQ by R.
Conducting sphere है तो KQ by R होगा. अगर नॉन कंडक्टिंग स्फीयर है तब 3 by 2 KQ by R होता है. ठीक है, इसका डिटेल्स विल बी इन गॉस लॉ. नॉन कंडक्टिंग सॉलिड स्फीयर चार्ज्ड के का पूरा डिटेल्स इन गॉस लॉ.
And so there's an oil questions.
सॉरी,
So in that there are oil questions. There's some oil
मिलिकन
drop
ऑयल
question.
ड्रॉप, वो तो कुछ भी नहीं है यार, वो तो यूनिफॉर्म इलेक्ट्रिक फील्ड है, उसमें अगर एक पार्टिकल को रिलीज करते हो जिसमें कुछ नेगेटिव चार्ज है या पॉजिटिव, तो आई कैन से दैट QE फोर्स और mg फोर्स एक दूसरे को बैलेंस करते हैं. दिस इज नथिंग. Okay, let's go to DCP. Yeah, tell me.
Sir, if there's a solid sphere of radius A and the charge minus Q is uniformly distributed throughout its volume, so what will be its potential energy, sir?
वो तो डिस्कस किए थे. अगर सॉलिड पूरा 3 KQ स्क्वायर बाय
area पर.
सरफेस पे है तो KQ स्क्वायर बाय 2 और पूरे वॉल्यूम पे है तो 3 KQ स्क्वायर बाय 5 आर. सेल्फ एनर्जी वाले टॉपिक में डिस्कस किए थे.
सर होम असाइनमेंट से भी एक डाउट.
हाँ, ठीक है, करते हैं. पहले लेट्स डिस्कस द
So I had a doubt in the example you are given.
ओके, लेट्स फर्स्ट डिस्कस DCP. या प्लीज टेल मी, DCP से कोई डाउट है तो.
So page number 121, that example is there. No, example 24.9. I had a doubt in that.
ओके, फ्रॉम DCP. ओके,
Yes.
म्यूट कर लो. शिट, लॉट ऑफ नॉइज देयर. तो 121, लेट मी गेट
Yes, sir. This example.
Yeah, tell me, what doubt do you have?
So 24.9.
24.9. Okay. So 24.9 is a good question. You guys, everyone can try it out if you've not tried it out. तीन forces है, right? Tension, weight, and F. And then when they are in air, now it is dipped in some liquid, and it is said that the angle between the two charged balls do not change. Okay, the angles remain same even when dipped in liquid. In vacuum, they are making an angle theta. In liquid also, they are making the same angle theta. Right? In liquid also, they are making the same angle theta. So if they are making the same angle theta, what is happening at over here? The electric force decreases because of dielectric constant, and the effective weight decreases because of the upthrust. You know, so W dash becomes W minus U, and Fe dashed is what? Fe dashed is Fe by K. Right? Now we can say that T cos theta and T sin theta were terms, right? What will that be? T cos theta is equals to W, and T sin theta is equals to Fe. So I can write down tan theta as what? Tan theta can be written as Fe by W. So since tan theta remains same, I can write down Fe divided by W is equals to Fe by K in the second case when it is dipped in liquid divided by W minus U. So you can just solve from this, right? Weight को क्या लिखेंगे? Volume into density of the body into G, right? And upthrust will be volume into density of the liquid into G. So we'll get it as again volume and G's will cancel out. So 1 by rho is equals to 1 by K into rho minus sigma, so to say. Right? तो यहाँ से आंसर आ जाएगा. यहाँ पर लैमिस थ्योरम वगैरह किया नॉट नीडेड. ओके, कोई भी टू balls suspended, right? Two pendulum suspended वाले problem, this is the best way to approach. Tan theta से. Okay, next. Exercise problems. Tell it out, please. Exercise 1. Any doubts? First 10 questions, first 5 questions, any doubts? 1 to 5, 6 to 10. No doubts.
So number 12.
Number 12. 12 is again on the chart sheet. So that'll be next class problem, right? Gauss law में है इसका discussion. Up to 15, any doubts? 16 to 20.
So number 18.
Number 18. 1,000 drops of same size are charged to 1 volt each. They coalesce to form a single drop. Then what will be the potential? So I can say that V is equals to what? KQ by R. Okay. Now the new drop will have how much charge? 1,000 Q. So the 1,000 drops है. And what radius will they have? Volume is what? 4 by 3 pi R cube. ठीक है, तो वॉल्यूम 1000 टाइम्स हो जाएगा, but the radius will be how much? The radius will only be 10 times. This volume is what?
Yes, sir.
1000 V, right? The original volume, if I assume, is small v, right? Then I can write it as 1000 into 1000 into small v is proportional to r cube, and small v की जगह मैं क्या लिख सकता हूँ? Small r cube. So 1000 into small r cube is proportional to capital R cube. So capital R is what? 10 r. So you'll get it as 100. अगर इसका और ये V का वैल्यू 1 वोल्ट दिया हुआ तो 100 into 1 will be 100 volts. Okay.
Yes, sir.
Next. Up to 20, any doubts? 21 to 25. Again, flux from the next lecture you can try. 26 to 30. Solve किया हो या नहीं किया?
So 32.
Okay. 32 is infinite line charge. Okay. ये सब जो भी infinite sheet, infinite line charge, flux, right? All of this will be Gauss law, right? Solid, uniformly charged, non-conducting sphere. They're all Gauss law topics. Right? Next,
So 37.
33 is also same. Infinite line charge. 37. 37, I think we are done in room session 2. चार्ज क्यू है, रेडियस आर, और एक दूसरा रिंग है वो भी चार्ज क्यू, रेडियस आर, एंड दे आर डिस्टेंस अपार्ट फ्रॉम ईच अदर. दिस इज कैपिटल क्यू, दिस इज माइनस क्यू. पोटेंशियल डिफरेंस निकालने के लिए सेम ही समझ जो अपन किए थे. इस पॉइंट ए पे पोटेंशियल क्या होगा, रिंग ये प्लस क्यू के कारण के क्यू बाई आर, और ये जो माइनस क्यू के लिए ऑल द पॉइंट्स आर एट व्हाट डिस्टेंस, आर स्क्वायर प्लस डी स्क्वायर, दिस लेंथ इज डी. So I can write down the potential at A as what, kq by r, and k minus q by d square r square. Similarly, you can find out the potential at B, minus kq by r because of the negative charge, and because of the positive charge, the distance is under root d square r square. And so potential difference will be twice. Minus करेंगे ना, तो सब signs change हो गया, तो potential difference will become twice this one. Go through it please.
Yes, sir.
Delta V is twice VA, so to say. I think the answer would be D delta. Next. Subjective, any other doubts from the objective questions?
सर बुक में 70 क्वेश्चन है लेवल 1.
बुक में 70 है और यहाँ पे 39 ही है.
हाँ 70.
बहुत ही दुख का बात है. You can forward me if you want.
ओके सर.
I can discuss them. So let's first check over here if you have those questions. Level 2 में ऑब्जेक्टिव में कोई क्वेश्चंस है?
So number 2.
Question number 2.
Yes, sir.
Okay. You have to find out electric field. तो kinetic energy V से 2V हो गया speed. So I can say that the electric field exists in a region. तो ये 30 degrees है, तो ये वाला component 2V sin 30, तो ये V रहा. Okay. And so whatever increase in velocity has happened must have happened over here. So root 3V velocity है, I can say. Okay. Then the electric field has to be in the horizontal direction. Okay. Now, since it is an electron, it is accelerating rightwards. The electron has accelerated rightwards. It means that the electric field must be in the leftward direction. तभी electron rightwards accelerate करेगा. See if you're clear with this. And if the electric field is E, then I can say that the acceleration of the electron will be how much? Acceleration will be QE by n. Charges E, small e by n. Or over a distance d, horizontal distance कितना travel किया d? Over a distance d, it has gained a velocity of root 3. So I can use Vx square is equals to Ux square plus 2Ax into Sx. Along x use कर रहे. Why am I able to use this? Because it is a constant acceleration motion. Initial velocity 0 था, acceleration we know is E by m, and displacement along x is d. तो यहाँ से velocity along x आ गया, which is what? Which is root 3v. तो उसका स्क्वायर करेंगे तो 3v स्क्वायर हो गया. So you get it as 3mv square by 2EEA. That is the value of E. okay, and it is in the negative y direction. Negative y direction तो already conclude कर लिए थे because the electron was accelerating by, और यहाँ से magnitude आ गया E का 3mv square by 2e into a. This distance is a. Sorry, this distance is a. Horizontal distance a. Vertical distance is b. Horizontal distance is a. That is what we are interested in. Okay. Please go through. If you have doubts, please ask. इलेक्ट्रिक फील्ड का वर्क डन कितना हो गया यहाँ पर? इलेक्ट्रिक फील्ड का वर्क डन इज इक्वल टू द चेंज इन काइनेटिक एनर्जी. तो बहुत ही आसान है, राइट? एनी अदर डाउट्स?
Yes.
Okay.
The 6.
Question number 6. ये सेल्फ एनर्जी से करना है. Initially, there is charge on the inner conductor Q. यहाँ पर minus Q, इधर पे plus Q. Okay. So this can be done by self energy. Work done to accumulate all those charges, right? You can find that out. And then between the two conductors, how much is the self energy? You can find that out. And once you close the switch, what will happen? All the charge will flow to the outside. So initial energy calculate कर लो, final energy calculate कर लो, and then the heat is initial minus final. ये problem और भी better तरह से capacitors में कर पाएंगे. Capacitors, once we do capacitors, you'll be able to understand this problem much better. As of now, this much will do. Next. Objective say any other doubt? into 20. Objective 2. (21 to 25).
24.
24. ओके, तो यहाँ पर ये वर्टिकल सर्कल का प्रॉब्लम है. तो जस्ट अ क्विक रिकैप ऑन द वर्टिकल सर्कल. मिनिमम वेलोसिटी यहाँ पर कितना होता है टू कंप्लीट द सर्कल? √5 here. Okay, this is the maximum velocity that you this is the minimum velocity that you have to give. And critical condition topmost point पे होता है. The minimum velocity there should be what? 2g here to just complete the circle. Okay, so why is this the point of zero tension? Because all forces apart from tension. What is the only force apart from tension? mg. That is towards the center. So critical point कौन सा होता है जहाँ पर string slack just होता है, right? So at that point, how do we find out that point? When the resultant of all other forces apart from tension is towards the center, उस समय tension का requirement is minimum. P required is minimum when the resultant of all external forces is towards what? Is towards the center. Why? Because they themselves can provide the required centripetal acceleration. So tension का requirement ही नहीं. Okay. तो यहाँ पर और once you get the critical point, तो उसके उल्टा point is the highest velocity point. Please remember that critical point के उल्टा तरफ will be the highest velocity point. Highest velocity, maximum, highest tension, maximum velocity, maximum tension. That is the point. तो अब यहाँ पर critical point कौन सा होगा? यहाँ पर there are two forces in the charged particle apart from tension. What are those two forces? mg और qe. तो जब mg और qe का resultant is towards the center, somewhere over here, mg and qe का resultant, all forces apart from tension must be towards the center. The resultant of all forces apart from tension, resultant of external forces apart from tension, okay, apart from tension is towards the center. तो यहाँ पर होगा, right? I can say that if this angle is theta, then ये वाला angle भी theta होगा. And so tan theta is perpendicular by base. I can write it as QE by mg. Right? So at this point, the tension is minimum. यहाँ पर टेंशन का रिक्वायरमेंट सबसे कम है क्योंकि ये दोनों फोर्सेस का रिजल्टेंट ही टुवर्ड्स सेंटर है. तो सेंट्रीपिटल एक्सेलरेशन वही प्रोवाइड करते थे, तो यहाँ पर मिनिमम टेंशन होगा, एंड सो दैट इज 0। तो मैक्सिमम टेंशन अगर निकालना है तो वो किधर होगा, वो उसके उल्टा पॉइंट पे होगा। ठीक है, क्लियर होगा। तो यहाँ पर ये वाला एंगल थीटा दिया हुआ है, तो यू हैव टू डू 180 एंड देन यू हैव टू गेट दैट मच एंगल। ये वाला वैल्यू थीटा दिया हुआ है, तो यू हैव टू गो फ्रॉम दिस पॉइंट टू दिस पॉइंट। दिस इज द वैल्यू ऑफ थीटा दैट इज नीडेड इन द आंसर, राइट? So how much is this? 180 degrees plus that angle that you found. So pi plus that value. So pi plus that tan inverse QE by n. Go through it, please. Okay. Next. This is 30. No doubt, friends. 30.
32.
32. हाँ, ये एनर्जी डेंसिटी वाला प्रॉब्लम अगेन कैपेसिटर्स में, इलेक्ट्रोस्टैटिक प्रेशर, एनर्जी डेंसिटी, ये सब कैपेसिटर्स में। Please remember, electrostatic pressure, energy density, then capacitors. Next, we done a problem like this in Zoom session 3. Please go through that if you haven't yet gone. Okay, so let's go to the PDFs a few students have shared. Okay, so Madhav has shared the PDF. Let me just open that. So ये 27 वाला question we have already done. The answer is D. 31. Which one, Madhav?
Yes.
31 करना है। आना तो बोल माधव।
हाँ सर।
Okay. Charge Q is distributed over two concentric hollow spheres of radius r and capital R such that the surface charge densities are equal. The potential at the common center is what? Simple question. We done a potential at the common center निकालना है. This is the configuration. Radius small r and capital R, और charge densities same दिया हुआ है. Distributed two concentric hollow spheres such that the surface charge densities are same. तो अगर यहाँ पर चार्ज Q है तो इधर पे माइनस Q होगा, राइट? और यहाँ पर कितना होगा चार्ज फिर? Q प्लस Q. No, just Q. Go through it, please. Charge Q is distributed over two concentric hollow spheres. So if the charge is small q over here, the charge left for this conductor will be Q minus Q. उसमें से माइनस Q इधर आ जाएगा तो इधर पे बाहर पे Q रहेगा. See if you are able to understand this much. दो कंडक्टर से एक पे स्मॉल Q चार्ज दिए तो दूसरा पे क्या बचेगा? कैपिटल Q माइनस Q. उसमें से माइनस क्यू इधर आ गया तो बाहर वाले पे कैपिटल क्यू बचा. नाउ द चार्ज डेंसिटीज आर इक्वल, द रेडियस इज स्मॉल r and capital R. So what is the value of sigma? Sigma can be written as q by 4 pi r square. And for the other conductor, what is the total charge? Q minus q divided by 4 pi capital R square. So sigmas are equal. तो यहाँ से ये इक्वेशन आ गया. And now you can find out the potential. तो यहाँ से small q का value we can calculate. है ना? Small q is what? Q by small q can be calculated from this, right? And then we can find out the potential. Potential का expression will be k small q by small r plus k into q minus q by capital R. Please go through. Okay. Fine. Next, 32 is based on Gauss law. Leave that.
सर 44 का A wrong क्यों है?
44 में q and minus q are held at minus a and a. Electric field is same at all the points on the x-axis. Electric field at all the points on the x-axis. So between the two charges, the electric field is in the opposite direction. यहाँ पर और यहाँ पर ये तो अपने बोलते हैं कि ये एंड ऑन पोजिशन है, एक्सियल पॉइंट्स है. तो इलेक्ट्रिक फील्ड इज इन द डायरेक्शन ऑफ द डाइपोल मोमेंट. तो डाइपोल मोमेंट अगर राइटवर्ड्स है तो यहाँ पर भी इलेक्ट्रिक फील्ड राइटवर्ड्स और इधर भी इलेक्ट्रिक फील्ड राइटवर्ड्स. But if you see between the two charges, the electric field at any point will be leftwards because of both the charges. So between the two charge particles, the electric field is opposite to the dipole moment. Okay. Please go through. Next 45.
नहीं सर, next page.
Okay. 66 solid sphere का problem है. Next class. 5 conducting balls numbered 1 to 5 are suspended using separate threads. Pairs 1, 2, 2, 4, 4, 1. Electrostatic condition, electrostatic attraction, and 2, 3, 4, 5 show repulsion. Okay.
सर इसका आंसर सी आएगा पर
Neutral होना
पीछे
चाहिए
ए दिया हुआ है.
हाँ सर.
देखते हैं. 5 conducting balls. Attraction है between 1, 2 तो 1, 2, 2, 4 and 4, 1. नहीं यहाँ पर do not consider your ये इंडक्शन वाला चीज इग्नोर करके ट्राई करने का है ना. लेट्स सी. अट्रैक्शन है तो ऑपोजिट चार्जेस होगा. तो ये माइनस है तो ये प्लस. नहीं 5 balls they show attraction so they must have opposite charges. And 2, 3, 4, 5 show repulsion. So if they show repulsion so they must have same charges. So we should start from that. तो ये अगर प्लस है तो ये भी प्लस होगा और ये माइनस है तो ये भी माइनस होगा. So 2 is plus, then this guy should be minus or neutral. 2 is plus, so this guy should be, ये तो माइनस दिया हुआ है. This is minus, so this guy should be plus or neutral. तो न्यूट्रल ही आया ना.
हाँ सर,
न्यूट्रल
आंसर पॉजिटिव दिया था.
नहीं न्यूट्रल है, ठीक है.
तो दोनों हो सकते हैं.
इसमें 2 can be neutral.
2 can be neutral. नहीं 2 कैसे न्यूट्रल हो सकता है.
Induction से attraction हो सकता है.
नहीं रिपल्शन हो रहा है तो these two must be positively charged. ये चारों बॉडीज को तो चार्ज होना होगा क्योंकि रिपल्शन is a sure test of charging. इलेक्ट्रिफिकेशन का short test है, ठीक है ना. समझ में आ रहा है. तो 1 has to be neutral. Yeah. Next quadrupole मतलब दो डाइपोल, ठीक है. The point P is the perpendicular bisector. You have to find out the electric field. तो दो डाइपोल लेके सॉल्व करना और कुछ नहीं इसमें. ये एक डाइपोल है, ये एक डाइपोल है. तो यहाँ पर थीटा का वैल्यू हो गया तुम्हारा, कैलकुलेट कर लेंगे. और यहाँ पर भी थीटा का वैल्यू अकॉर्डिंगली कैलकुलेट कर लेंगे. तो पोटेंशियल आ जाएगा. केपी कॉस थीटा बाई आर स्क्वायर फॉर्मूला होता है ना, तो वो यूज करना है. ठीक है, क्लियर विद दिस. टू टर्म्स of kp cos theta by r square to be added. क्या दिया हुआ है इसमें आंसर?
से इसका आंसर नहीं दिया हुआ मेरे बुक में.
अच्छा, बुक में आंसर दिया हुआ है. बहुत इजी था. फील्ड, इलेक्ट्रिक फील्ड निकालना है. इलेक्ट्रिक फील्ड का वैल्यू निकालना है. ओ, नॉट पोटेंशियल, सॉरी. दिस वाज अबाउट पोटेंशियल. इफ आई हैव टू टॉक अबाउट इलेक्ट्रिक फील्ड, तो इसका इलेक्ट्रिक फील्ड होगा ई आर और ई थीटा, राइट. ये सेकंड क्वाड्रेंट हो गया एक पहला वाला डाइपोल के लिए. तो पहला वाला डाइपोल के लिए ई आर किधर होगा बता सकते हो? ई आर और ई थीटा वाला फॉर्मूला में क्या आता था? या फिर इसको ब्रेक करके कर सकते हैं, डाइपोल मोमेंट्स को ब्रेक करके कर सकते हैं, राइट. ईदर ऑफ द टू वेज वी कैन यूज. आई कैन से दैट दिस डाइपोल कैन बी ब्रोकन एज सच एंड एज सच. So this point P is a end-on position for the black dipole. Sorry, broadside on position for the black dipole, and so electric field उसका किधर होगा? Opposite to the dipole moment. And so this is E parallel, you can say. Yeah, E by 2 आ जाएगा ये, है ना. And it is at a end-on position for the blue dipole. So the electric field will be E in this direction. देखो समझ में आ रहे हैं. Same thing can be done for the left dipole. Left dipole can also be broken into two, right, along the radial line and perpendicular to the radial line. So because of the perpendicular, this point is a broadside on position, तो यहाँ पर ये E by 2 आएगा, and because of the blue thing, it will be E. So I can say that the resultant electric field is what? The resultant electric field is vertical downwards. और E by 2 का expressions हमें पता ही है खूब. तो 1 by r cube होता है दोनों में. So it is 1 by r cube towards the negative charge. 1 by r cube.
सर 1/r4 होगा ना.
इलेक्ट्रिक फील्ड निकालना है. इलेक्ट्रिक फील्ड तो r स्क्वायर r क्यूब ही तो होता है ना. kp cos 2 kp. E का वैल्यू क्या है? 2 kp by r cube. E by 2 will be kp by r cube. Okay. So 1 by r cube is the electric field, but it is towards the negative charge, not away from it.
That's option.
That is so.
The answer option C है.
1 by r4 towards the negative charge. अच्छा. 1 by r4 कैसे आएगा? Towards negative charge makes sense. I can say कि इलेक्ट्रिक फील्ड का कंपोनेंट्स अगर लेंगे तो वहां पर एक cos थीटा का टर्म के कारण आ सकता है. दैट इज ऑल वी कैन, मैंने आई कैन थिंक एज ऑफ नाउ. मतलब दोनों E by 2 का जो रिजल्टेंट आएगा वो क्या होगा? सो द रिजल्टेंट इलेक्ट्रिक फील्ड आई कैन राइट इट एज व्हाट? E resultant can be written as 2E by 2. If I call this angle as theta, then 2E by 2 cos theta by 2, है ना. See if you are able to understand this. या फिर हाफ एंगल को ही अगर थीटा अज्यूम करते हैं. If I assume this much angle as theta, then it will be 2E by 2 cos theta. And because of the blue electric fields, it will be if I assume this angle as phi, then will be 2e cos phi. देखो समझ में आया या नहीं? तो e वाला टर्म्स में 1/r³ का रिलेशन है और cos phi वाला टर्म में क्या होगा? cos phi will be based by the hypotenuse. तो एक r कम हो जाएगा उस केस में फिर। नहीं यार, theta is small, नहीं, theta is not necessarily small. एक्चुअली लोग इसमें फिर वो नहीं कंसिडर किया यार, दैट इट इज अ शॉर्ट और डाइपोल, राइट? तो शॉर्ट डाइपोल इनको कंसिडर करना चाहिए था। अगर नेट इलेक्ट्रिक फील्ड निकाल रहे हैं तब तो आर एंड एल का अगर ये रिलेशन नहीं दिया हुआ है, if you have to convert, if then you'll have to use the bigger way of solving it, है ना? मतलब जहाँ पर ब्रॉड साइड ऑन पोजीशन में we write it as kp by r square minus l square वाला टर्म होल स्क्वायर, उस तरह से फिर लिखना होगा, राइट? फिर सॉल्व करना होगा, तो वहां से आएगा। ट्राई करना है इसको, एनीवन, राइट? लेट मी नो इफ यू गेट टू द राइट आंसर। ओके, नेक्स्ट, दिस इज ऑल फ्रॉम the sheet. Anyone else who's shared?
सर संगेज का डाउट्स भेज देगा अभी।
संगेज अभी रहने दे,
भेजा आपको
संगेज अभी रहने देते हैं। Let's do Sangeet sometime else, right? Sangeet and maybe part 2 of the booklet, we'll do it sometime else. Okay. Cool.
So I
Let's
had
talk
doubt
about
from
this.
the lecture.
Yeah, tell me please what doubts you have.
So that potential difference and so potential difference and torque equation in dipole, you did the proof. That one I couldn't understand properly.
Potential difference for the equation for the torque or equation for the potential of a dipole?
So relation between torque and potential difference for a dipole.
Relation between torque and potential difference. Okay. So if I assume that there is a uniform electric field and I place a dipole, then it will experience a torque, right? If I assume this is the dipole,
Yes.
then it will experience an electrostatic torque because of the electrostatic force. And so if I have to rotate it in the opposite sense, then I'll have to apply torque in the opposite direction, right? And in that way, if I want to rotate it from an angle θ1 to θ2, then how much work is done is nothing but the change in potential energy. θ2 is the final angle and θ1 is the initial angle, right? So we had found the work done by the external torque to rotate it from θ1 to θ2, right? So what will that be? That will be change in potential energy. That's a relation, right? And what is change in potential energy? P final minus P initial. What is the final potential energy? Minus P cos θ2. And what is the initial potential energy? Minus P cos θ1. And so we get as P cos θ1 minus cos θ2. Okay. What is the work done by the torque of the electrostatic force? That will be negative of this value. P initial minus P final, right? Okay. Work done in this process. What is the work done by the torque of the electrostatic force? That will be minus of change in potential energy. This is your work energy theory. Work done is negative of the work done by the internal conservative force here. It is the internal conservative torque is negative of the change in potential energy. Is this your doubt? Have I been able to understand it clearly?
Yes, sir. Yes, sir.
Okay. Any other doubts? Anyone?
Sir.
Yes.
So image techniques सिर्फ grounded conductors के लिए use कर सकते हैं क्या?
हाँ. Did we cover that in the video lecture?
So वो वाला part नहीं था.
Okay. So we'll do it in the next session, right? Next Zoom session जो होगा Gauss law के ऊपर we'll cover that. Right, so let's stop at this. We'll meet again on Saturday, right, with Gauss law and stuff. Sorry, not Saturday. Yeah, Saturday. I'm not so confused. Okay, yeah. Saturday.
Saturday.
Yes, yes, Saturday. We'll meet with. We'll discuss Gauss law. Has that been uploaded on the website?
Yes, sir.
Yes, sir, it was uploaded today only.
Cool, cool, cool. So I'll give the homework with it, and I'll please watch it well because it is an important thing. And we'll discuss the problems on Saturday. Meanwhile, this week we'll be doing one-on-one sessions. Many people have already asked for it, right? I was slightly busy in the last couple of weeks, so we'll do one-on-one sessions in this week, right? Be it doubts from previous topics or doubts from electrostatics, whatever. Feel free to approach. Okay. Bye bye. See you.